About that. Were you in a weakness for the office? No, that's what I did. Where were you? Release. All right, let us get to it. So you learned yesterday how to do how to do the basics, how to get simple quadratics written in standard form converted over to Vertex. Hopefully you got that assignment 32 done. That's under the water under the bridge. And now we have to tackle, got some fuzzies on my computer there. Oh gosh. Oh, she needs a wipe down. Need some baby oil on that. Yeah. So let's do this. Four examples today, four problems again on your homework assignment. So I don't know how long this will take, but these are a little bit rougher. Again, it always depends on who you're talking to. Like if you have good basics with fractions and just basic skills in general, it won't be that bad. But it's can be a bit rough. So we're going to start by doing what we did yesterday, and that is focus on getting this thing by itself. So whatever is stuck to it is what we're going to pull out. And remember that we only pull it out of these first two terms like this. So same setup as yesterday. We're going to take the y equals. We're going to pull out the 1/3. We're going to build a nice long set of parentheses, and then we're going to kick the 19/3 out. As tempting as it is to make identifications, like to see that, hey, I could pull a third out of all of those, I still maintain you want to avoid that just because having that number off to the side just makes the whole completing the square process just feel so much cleaner and quicker. So I maintain this. And having done it both ways, I can just tell you from experience, I think you're going to benefit from just keeping the 19/3 or whatever number's out there, just kick it out. All right. So if I pull 1/3 out of the two red underlined terms, what do I get? What does the first term become? X squared. Yeah, I mean, it used to be 1/3 x squared. If we pull out the 1/3, now it's just x squared. What does 10/3 of x become if we pull out 1/3? It is not 3. I might have heard someone whisper it, but I can't. Yes. I was not sure if that's what you said. Good job. And you can check these always by, there's a couple different ways. I mean, there's a way to calculate it actually, which I'll show you, maybe on a harder problem, but you can also just check it. If you're not sure if you did it the right way, then just, don't be a lazy bones. Just multiply these two yellow arrows back out. Does that yellow arrow equal what we started with? Yes. And does this yellow arrow equal what we started with? Yes. So we can tell we're having success if what we create equals what we started with. Okay. And that step's going to get a little bit tougher as we go through the next examples, just FYI. But I think in a case like that, pulling a third out of 10/3 is relatively straightforward. You essentially just yoink the denominator out and then drop down the 10. So now we're back into our comfort zone at this point, right? So we see now that the 1/3 can be put aside, the 19/3 can be put aside, and what we're focused on is right here. And we are going to complete the square. So all of the things that could cloud our understanding at this point, again, put them aside and just focus. What's half of plus 10? 5. Plus 5. And you know how I feel about this. I'm going to write it down. And then I'm going to square it. And what am I going to get? 25. I'm going to get 25. So I'm going to add 25. And again, as per our discussion yesterday, we understand now that we have to erase those footprints, right? We want to make it like we were never here. So what will I do at the tail end, way over here, to make it like this red number never happened? Subtract what? Correct. We will subtract 25/3. And, no matter how many times we go through this, even, bless you, even 2 or 3 days from now, we'll still be getting the questions of how did I get that red number? And my answer will never change. ever. My answer will always be, till the end of time, take this number that you pulled out earlier and multiply it by the number that you used to complete the square. Remember, what that yellow arrow does is huge. It reveals the true identity of the red number. He's not a 25, right? He's a 25 times a third, which is 25 thirds. And the way to erase a 25 thirds is with a minus 25 thirds, right? That's the whole process. There's going to be a little bit more complexity as we progress through the next examples, but this one's done. All we have to do now is just cash in, what we came here to do. We have y equals 1/3 times something squared. What's the something squared? Yes, it is x plus 5. And then in the back end, this is where, again, you just have to have some simple basic skills. What's 19 thirds minus 25 thirds? Correct. It's -2. And the reasoning behind that, I'll just show this for some of you who might want this, is that it would have been -6 thirds. And we, of course, know that that equals a whole number, 2, right? So at the tail end of this, I can just put a nice, simple, clean -2. And at this point, graphing it, of course, know where the vertex is, right? And again, I don't intend to graph with you today. I feel like we've already kind of covered that. The expectation is still that you would do it on an assignment, but you know the drill, I think, by now. So where is the vertex at, though? Yeah. And then as far as the graph, you'd go to that point and then it would open upwards and it would be a chunker, right? Not a mega chunker, but fat. Like you're going to have a lot of points that you'd have to graph there because your verticals are going to rise a third as fast as they normally would. Okay. 1 down, 3 to go. Next one. F of x equals -3/4 of x squared plus 3x plus 1. The math starts right away. I think with yesterday, it was everything we could pretty much just do in our heads. Like, if we pull out a 2 and it used to be an 8, it's like, ooh, it's a 4. Like that was really easy. But this is where the difficulties can lie for some of us. Again, it just depends who you are. So the beginning is what it is. I'm going to bring down my f of x. I'm going to pull out -3/4. I give zero craps about how the 3/4 is going to affect the other number. I don't care. Like I'm going to pull off whatever is stuck to the x squared, right? So I'm going to have -3/4 pulled out. I'm going to have a nice long set of parentheses, and then I'm going to kick the +1 to the back. When someone walks up and says, could you help me? I don't know what to do. It's like, well, you got to at least do that because I have done quite literally no math yet at all, right? I've simply followed a step, right? A simple directive. And even this, I haven't done any math really, right? But this is where it begins. So the question at this point, there's two mega issues with this process. Mega issue number one, I know this from experience, where I spend all my red ink when I grade these. Like when we quiz on this, like Tuesday or whatever it is, almost all of my red ink will be spent on people trying to figure out what number goes here, and then people eventually trying to figure out what number goes here. Those are the hot spots. So let's first talk about the yellow arrow there. Anyone got a shot at what this is going to be? There's a way to do this, and I haven't had to show you this before because, again, I don't think we've had to do any. I haven't had to show you work. I want to go back again. Like if this was an 8 and this was a 2, then it would be like, well, duh, I'll put a 4 here, right? Because just common sense. But we haven't actually had to employ any sort of procedure to this point. Anyone have any thoughts on how I could calculate what will go in place of that 4? Study the 3 red numbers on the board and come up with a conjecture. What is 4? It is. Good observation. So according to DeLong's theory, I should be able to take the red number up here and consistently, commonsensically, divide it by the number that I pulled out and get the number that I need. And again, we haven't had to think in these terms yet because it's been childishly simple to figure out what this number is. But now we have to give it a little bit of respect. We have to now think in terms of, okay, hmm, I got to do math. So I'm going to take the top number, the OG number in the middle, the 3, and I'm going to divide it by the number that I pulled out, -3/4. I'm going to say that again. You really want to do that. You really want to get good at that because not knowing what the middle term is going to just completely destroy, explode the whole rest of the problem. And so here's basic test number one, basic skills test number one is can I do 3 divided by -3/4? And the answer is, of course you can. You're in high school, right? So we're going to take the 3. We're going to write it as 3/1. We're going to change the division to times, and we're going to switch the second fraction to -4/3. Copy dot flop is going to be your bestest friend on this step with fractions. Again, without fractions, you don't need it. What is the answer to my bottom purple problem over there? Say it again. Negative, did you mean?
Yeah.
It is negative, I agree. And it is 12 thirds, but we can do better than -12 thirds. What does that equal? Yeah, so believe it or not, after all of that, the number that we need to put right here is -4x. And I'll say what I said 5, 6 minutes ago, and that is if you don't know if you're not vibing with that number, if you're like, I don't know, man, that seems a little like sus or fishy to me, then don't be a lazy bones. Just take this and multiply them together. Test it and ask yourself, does the result of that yellow arrow equal the number that used to be there? And if the answer is yes, then pat yourself on the back. Nailed it. Okay, and now we return very briefly to business as usual. And the business that I'm referring to is completing the square. So my focus at this point immediately goes to completing those parentheses. And this is an algorithm, a process, a procedure that you're intimately familiar with. What's half of -4? -2. Square that. What do you get? So I'm going to add 4. I should put that in air quotes, 4. Because as you know, this cat got let out of the bag yesterday. The secret's out. That's not really a 4, is it? What is the true value of that number? It's -3. That number that the green arrow is pointing at, he's like a trickster, a prankster. He's like, look at me, I look like a 4. And then we identify by doing just some relatively simple math that if we take this number times this number, we're like, you're not, you're, that's not what you are. You're a -3 in 4's clothing. And we can calculate that by just doing what the yellow arrow says. What is -3/4 times 4? Well, cancel out the 4's and it's -3. So that number with the green arrow pointing at it says, I look like a 4, but I'm actually a -3. Psych. And how do we erase that -3? We add 3 to the back. What a convoluted, potentially confusing mess we've got. The 2 steps are key. The first one where we divide the OG middle number by what we pulled out, massive. And the second one is the yellow arrow revealing the true identity of the number that we use to complete the square. And at this point, we're done. I say we're done, but you know what I mean. Like we're done. All the heavy lifting is over. What's the final answer on this one? What goes in here? X minus 2. And I shouldn't, I'm sorry, I was a bit hasty in erasing that original number. You're fine. If that's the worst thing that happens today, that's going to be a glorious day, right? How we feeling? 2 down, 2 to go? This is not a freestyle situation. You don't want to go rogue. You want to follow these steps like to the letter. Let's go again. Round three. So Vertex on this one would be at 2-4, obviously. It would open down and it would be just a mild chunker, like very hardly noticeably fat, because it goes down at 75% of its normal rate, which is, yeah, not much. Next one. Oh, that's a five. That's a better five. Step one. Can you see if Sleepyhead's you still with us there, Sleepyhead? Don't take that as a yeah. Say again? Not you. Behind you, you got Sergeant Slumber there. He looks like he's ready to go. What's up? Okay. No skill involved in the beginning. None. In fact, you should be able 100% of the time. Just boom, there it is. Done nothing. Nothing but follow directions at this point. So the mystery number one, uh, massive mountain to climb number one is what number goes here. How are we going to calculate that?
5 divided by 5, 6.
Yeah, boy. So we're going to take OG middle number 5 and we're going to divide it by number that we pulled out, 5, 6. This works exactly 100% of the time. It's nice to know. 100. So to do 5 divided by 5, 6, I have to make 5 into 5 over 1. I have to multiply by the reciprocal, which is 6 over 5. Cancel those 5s. What do I get? I get 6. So I'm going to put a plus 6x in the middle. Hurdle number one, mountain number one, conquered. And now it's time to complete the square. So this is my current objective. What is half of plus 6? Yeah. Square that mambo jambo. What do you get? So I'm going to add 9. A 9 that's not really a 9. It's some other number in nine's clothing. And how do we unveil his true identity? Yes. Embrace the yellow arrow. Boy, that's the guy. So I'm gonna head out to the side and I'm gonna go do the yellow math problem. I'm gonna do 5, 6 times 9. Thoughts on that little calculation? Podemos reducir estos números. What can you divide 9 and 6 both by? Why don't we do that while we're here? Reducing is easier if you do it while it's out and exposed before you mash it all together. So if we divide those both by 3, he becomes a 3 and the 6 becomes a 2. What do we see his true identity is? 15 halves. Nice. I just didn't. Did you already say it? You guys are whispering at me today, and I can't hear. I'm already sick, and then my ears are plugged up, and you guys are whispering, which is sadistic. So you should just talk to me. So yeah, 15 over 2 is the true identity of the white-red combo with the yellow arrow. So when I added 9, I was actually adding 15 halves, which means at the back, I have to turn around and subtract 15. Sorry about that. It's like I had a little stroke there. Let me try this again. I'm gonna write like a big boy. There it goes. I did it. I did like a big boy. And what is 17 tooths minus 15 tooths? 2 tooths, which equals, oh, darn, I did it again. 1. So I have y equals 5, 6 times blank squared plus 2 tooths, aka 1. And what goes in the parentheses? X plus 3 squared. Not bad. Just a little foreshadowing before we do example four. The final difficulty level, which we will probably cross into tomorrow, maybe Monday, is that this number that I'm circling in green. What could I do to make your life a little bit worse? It could be a fraction or it could be odd. To this point, every single problem we've ever done, that number has been even. Could go back and check it. 16s, negative 12s, twos, fours, sixes, tens. So the final push with this is when that number circled in green is not cooperative, then that's it. Like I couldn't do really much more to make these problems any worse than that. So we're kind of we're reaching the upper level here today. We're just going to kind of go S tier tomorrow and one last jump or Monday. Where's the vertex? And how would you describe this graph? Almost normal opening upwards. 5, 6 is almost not even noticeable. It's less noticeable than its predecessor. 3/4 was not very noticeable. 5, 6 is like hurt near normal. So last one. Step one. Well, what? So pull out your -4/7. Make a big long set of parentheses and then boot lonely dude to the back. Oh, and I can also put my x squared in there because I'm not going to make it harder. All right. And so it begins. Just two mega steps, two mega monster steps. Number one is finding the number in the middle. And how do we do that?
48/7 divided by -4/7.
Yeah, you're the man. Purple guy divided by purple guy in the order that the arrow would suggest. Good job, Delon. So 48/7 divided by -4/7, right? Save a little time. Just dot flop as you go. What do you notice? Yeah, get rid of those sevens first off, like bam, bam. What else do you notice? 48 divided by 4 is 12. So we're going to have a -12 here. So we're going to put a -12x in the center. And again, what changes next time is that number is going to come out as a -11. And then half of -11 is -11/2. And when you square that, you have to add 121/4. And yeah, it's not a big deal. But it sucks a little bit more. A little bit. And now we complete the square. So what's half of -12? -6. Square it. What do you get? 36. And again, I need to know 36. Who are you? Reveal yourself. So let's do some basic math. We're going to do -4/7 times 36. You see anything we could do? Any reducing? I don't either, Landon. 36 and 7 don't play nice together. 4 and 7 don't play nice together. All of these numbers collectively are relatively prime to each other. Well, that's a lie. 36 and 4. The top ones and the bottom ones are relatively prime. So for that reason, we just suck it up and go, well, I guess I'll just multiply you out. That's what my teachers taught me back in the day. If I can't reduce, I just mash it. Big bulldozer from left to right. So I get -144/7. So the true identity of the red number is negative 144 sevenths. How do you offset a negative 144 sevenths? You add 144 sevenths. And it's these problems, I find them interesting because like 1 minute you're just in the mess and you take like one step and woof, the sun comes out and the problem's over. So we're there. It's over. So we're just going to state that f of x in its vertex form equals negative 4 sevenths of something. Oh, nice parenthesis over there. Let's try it again. I'm having a hard time writing like a big boy today. What goes in the parentheses? Yes. Thank you. That's good. At the back, look, plus 5. Yeah, if you take the top numbers, good basic skills. Negative 109 plus 44 is 35. 35 over 7 is 5. Got it? All right, let's do assignment 33. Let's get her done. GITER. Let's get her done. How you doing over there today, Coulter? What's that? Yeah.